All right, welcome to this video about rationalizing denominators. So it's convention in math that for many elementary levels of math, we don't show a radical in the denominator. There's a couple of reasons for that, but most of the time it's so that you can get used to simplifying and manipulating your radicals so that they all are in the same form. So if that's true, let's go ahead and fill that in. Fractions, which include radicals, cannot have a radical in the denominator. Radicals in the numerator are fine. So what we do is called rationalization. A square root is considered an irrational number if it can't be simplified to eliminate the square root. So we are going to try to manipulate this expression so that the denominator becomes a rational number using one of two methods. Okay. If the denominator only has one term, we're going to multiply both the numerator and the denominator by the radical piece of the denominator. Sometimes that's all you have is a radical in the denominator and you're ready to go. But sometimes you have more than just a single radical. For example, you might have something in the denominator that looks like this, 5 square root of 3. You would not multiply by 5 square root of 3 unless you want to create more work for yourself later. You're just going to multiply by the radical part, the square root of 3. Okay? If the denominator is a binomial, that means there's two terms and they're separated by a plus or a minus. You will multiply both the numerator and the denominator by what's called the conjugate of the denominator. Okay, conjugates, here's a little sidebar, are expressions with two terms that are added or subtracted. So let's say I've got A plus B. The conjugate of A plus B has the same two terms with the opposite sign. So A plus B and A minus B are conjugates. If I'm thinking about radicals, I could have square root of 3 minus the square root of 5 and the square root of 3 plus the square root of 5. These would be conjugates. Okay? All right, and so let's go ahead and try some of these examples. The first example is 15 divided by the square root of 6. Okay, so in this case, we only have one term in the denominator, the square root of 6. And so we're going to multiply both the numerator and the denominator by the radical part of the denominator. And in this case, that's all there is. So let's take 15 divided by the square root of 6 and multiply the numerator and the denominator by the square root of 6 over the square root of 6. And remember, when we're doing that, we are not changing the value of our original fraction because we are multiplying by a form of 1, which does not change the value. And that's why we can do this. Okay, so when you're multiplying fractions, remember you're just going to multiply straight across. 15 times the square root of 6 is 15 times the square root of 6. There's nothing I can do with that. Anything that's inside the radicals will stay inside and outside will stay outside. Now the square root of 6 times the square root of 6. Let's have a second to talk about that. The square root of 6 times the square root of 6. This is the same as the square root of 36, which is the same as 6. Another way to think about that is the square root of 6 times the square root of 6, that's multiplying the square root of 6 by itself, otherwise known as squaring the square root of 6. And if I square something that's under the square root symbol, they undo each other and we're just left with 6. Okay, so what we have here is 15 square root of 6 over 6. And now what we want to do with that is we want to simplify it. Notice this fraction. Both of those pieces are outside the square root, so I can simplify this fraction. 15 divided by 6, both of those pieces, numerator and denominator, have a common factor of 3, so let's divide that out. So we would end up with 5 square root of 6 over 2. And we're just going to leave that radical alone because we're just simplifying the piece that's outside the radical. All right. Next example. All right, so I see that in the denominator here, I've got the square root of 12. So before I get started on this, I am going to simplify the square root of 12. Let's just do that to the side. Square root of 12 is the same as the square root of 4 times the square root of 3, which is 2 square root of 3. Right, so I have 6 divided by 2 square root of 3. All right, let's go ahead and simplify this just a little bit more. What is 6 divided by 2? That's 3 over 1. So that's 3 over the square root of 3. Okay. All right, so now I still have my radical in the denominator. Let's rationalize that by multiplying by the square root of 3 over square root of 3. And in the top, when I multiply these things, I have 3 square root of 3. And in the bottom, I've got the square root of 3 times the square root of 3, which will end up being 3. Now notice in this fraction, I've got a 3 over 3, which is 1. And so that whole thing just ends up being the square root of 3. All right, last example. In this case, my denominator has 2 terms. I know it's 2 terms because it's separated by a plus. So if there are 2 terms, binomial, that means I need to use the conjugate. Okay, so I'm thinking about 4 plus the square root of 5. The conjugate of 4 plus the square root of 5 is 4 minus the square root of 5. So what I'm going to do is I'm going to take 8 over 4 plus the square root of 5 and multiply it by 4 minus the square root of 5 in the numerator and the denominator. So I will take this 8 and distribute it through, and I'll end up with 8 times 4 is 32 minus 8 times the square root of 5. Okay. Now in the denominator, I'm going to need to distribute the 4 to both these pieces and also the square root of 5 to both these pieces. So 4 times 4 gives us 16. 4 times negative square root of 5 is negative 4 square root of 5. Square root of 5 times 4 is positive 4 square root of 5. And the square root of 5 times negative square root of 5 is going to be negative 5. Now let's clean up that denominator just a little bit. Notice that I've got a positive and a negative 4 square root of 5, so these negate each other, and I'm just left with 16 minus 5. So my final answer here will be 32 minus 8 square root of 5 all over 11. I hope this helps you, and I'll see you next time.